Okay, I think we can get started. Good afternoon, everyone. Welcome to the Yale Sleep Medicine Grand Rounds. My name is Parthi Singh. I'm one of the sleep providers here at Yale. Before introducing today's speaker, a few housekeeping announcements. Please take a moment to ensure that you are muted. Please see instructions in the chat to receive CME credit for attendance and the one-time sign up for Yale CME profile to receive credit. If you think anyone else would be interested in joining us, please reach out to Debbie Lovejoy. If you have any questions or comments during the presentation, please use the chat room or take the opportunity to unmute yourself at the end of the talk and ask questions, and I will also moderate the session. Recorded versions of these lectures will be available on YouTube a few weeks after the presentation. Okay, now to our today's speaker. I have the pleasure of introducing Dr. Marie-St-Onge. Dr. St-Onge is a professor of nutritional medicine at Columbia University Medical Center and the director of the Center of Excellence for Sleep and Circadian Research. Dr. St-Onge received her bachelor's, master's, and PhD degree in human nutrition at McGill University. She completed her postdoctoral fellowship at Columbia University's Institute of Human Nutrition. She has authored over 100 publications. Her research, supported by numerous grants, explores the critical interplay between sleep patterns, nutrition, obesity, and cardiometabolic health. She has a passion for teaching both researchers and clinicians. Dr. St-Onge is an active member of both the American Heart Association and the Sleep Research Society. As a leader in her research field, I'm excited to have her join us at our Sleep Grand Rounds today. And now I'll turn over the floor to Dr. St-Onge for her presentation, Eat Well, Sleep Tight, Strategies for Good Cardiometabolic Health. Thanks for being here.
Thank you. Thank you so much for the invitation. It's my pleasure to talk to you about diet and sleep. It's something that we don't often talk about in the sleep field. So these are disclosures, CME credits. I don't know if I need to leave this on for a bit for the text or the code.
You could go on, we put it in the chat room.
Okay. So the learning objectives for this afternoon to understand the role of diet for better sleep, explaining the bidirectional relation between diet and sleep and how sleep is implicated in cardiometabolic health. And I know I don't really need to say this to this audience, but it's not that long ago that we published recommendations for adequate sleep duration at night for the American population. So the American Academy of Sleep Medicine, Sleep Research Society, and National Sleep Foundation all came together and published in 2016 these guidelines for adults to get at least 7 hours of sleep per night in terms of sleep duration. Unfortunately, many adults in the US don't get that much. Showing here are statistics for prevalence of short sleep, so less than 7 hours per night across adulthood in both males in blue and females in red. And we're seeing upwards of over 40% in some categories not achieving adequate sleep duration. And this is not necessarily equivalent across the US. There's some regions where we see a much higher prevalence of short sleep duration, mostly Southeast US, achieving rates of close to 50% of short sleepers in these areas. So we have a lot of work to do, especially when we also start thinking about metrics of sleep that are outside of sleep duration per se. And these are data for prevalence of reporting difficulty falling asleep or maintaining sleep over the past month. And if you look at the red and orange bars to the left, are the men and women, women in red, men in orange, who say they never have these difficulties over the past month. And it's about 30 to 45%. So over 60% of adults that say that over the past month, they've had some days or most or all days difficulty falling asleep or maintaining sleep. So to me, this is concerning. Everybody should strive to have adequate sleep duration, but also healthful, restful sleep. And we know that the effects of insufficient sleep are numerous. We very well know the impact on cognitive function, mood, learning abilities, but things that we don't necessarily feel are subtle changes that increase the risk of type 2 diabetes, risk of heart disease, risk of obesity, that are themes that my research is focused on. So, in terms of short sleep and obesity, I like to show this meta-analysis that was published in 2022 showing increased odds of developing obesity, so incidence of obesity in short sleepers that is increased across all strata of short sleep when we start falling below 7. And so I like it because it separates out different types of different durations of sleep, and you could see all above the one line, so increased odds starting at even less, just less than 1 hour uh, below the recommended 7 hours. And as you creep up towards less than 6 hours, and here less than 5 hours, the odds of developing obesity get even more pronounced. But it's not solely sleep duration that's relevant, and it's not only for obesity. The increased odds of cardiovascular disease are observed in individuals with sleep problems. The first box here, sleep duration, odds ratio of 1.4 for sleeping less than 7 versus 7 to 8 hours. Having long sleep onset latency greater than 30 minutes, odds ratio of 1.6. Saying yes to do you have any sleep problems, marked increased in the odds of developing cardiovascular disease, and also for daytime sleepiness. So not necessarily sleep disorders per se, and not solely sleep duration are relevant when we start thinking about cardiovascular disease risk. And so in 2016, with several colleagues of mine at the American Heart Association, we raised this issue with cardiologists that sleep duration and sleep quality were highly relevant for cardiometabolic health. And at that time, we had a lot of information from population-based studies showing associations, but really called here for additional research in diverse populations. We were lacking information from in women, in minority populations, and older adults. We asked for population-based studies to have longer follow-ups to be able to evaluate effect on various events. For clinical studies to be funded to establish causality, evaluate mechanisms, and also for researchers to include accurate and objective measures of sleep in their cohorts. So early on in my career, when I started evaluating the impact of sleep duration on energy balance regulation and obesity risk, we conducted very severe sleep restriction studies that were very short term. So this is a protocol for a study where we asked participants to spend either 9 hours in bed or 4 hours in bed for periods of 5 nights as inpatients in a randomized crossover design. Here we had 27 healthy males and females complete the study. During the 9 hour time in bed condition, they slept 7.5 hours on average. These were all individuals who were screened to have adequate sleep duration and good quality sleep to begin with. And during the sleep restriction condition, they slept about 3 hours and 45 minutes. We provided a controlled diet for the first 4 days and let them self-select their food intake on day 5, and we measured their intake throughout the day during this 24-hour period. And what we found was that sleep restriction increased their food intake by about 300 calories compared to the adequate sleep duration. And you may say this was solely on one 24-hour period, but there have been many studies that have been published since then, and meta-analyses that show on average increases in food intake of 250 to upwards of 400 calories per day due to sleep restriction compared to adequate sleep. Of course, when we have short-term studies like the one that we did, we really didn't have a chance to look at impact on weight. But more recently, in 2022, Covison and her group published a paper on 2 weeks of an inpatient intervention where participants slept about 8 hours per night during the habitual sleep condition versus a little over 4 hours per night during the sleep-restricted condition. And they noted changes in caloric intake. The red line is the daily energy intake during the sleep-restricted condition compared to the adequate or habitual sleep condition in blue. And in the bottom graph here showing increases in body weight, they found an increase in energy intake of approximately 260 calories, very close to what we had found over a single day, but this was over a 2-week period, which after this amount of time led to increases in weight of about half a kilo with predominant increase of abdominal visceral fat and waist circumference, which increased about close to 8 centimeters squared of abdominal visceral fat in this study. So those are very short-term studies. We wanted to follow up and do studies that were more representative of what we observe in population-based studies. So that is conducting studies where the sleep restriction is not so severe that it cannot be sustained for a prolonged period of time. So we conducted two sleep restriction studies in a randomized crossover design where we enrolled individuals who were habitual adequate sleepers, measured with wrist scintigraphy to screen people who achieved at least 7 hours per night over a 2-week screening period. And we asked them to sustain or to maintain this habitual adequate sleep over a 6-week period, or reduce their sleep by an hour and a half so that they would achieve about 6 hours of sleep over and maintained over a 6-week period in a crossover design. So after a 4 to 6 week washout period, they embarked on the alternate sleep intervention for the next 6 weeks. We measured body composition using MRI. We did oral glucose tolerance test at baseline endpoint. We collected endothelial cells to assess vascular inflammation and fasting blood samples throughout each intervention period. Our participants were very good at adhering to our sleep conditions. We asked them to keep fixed bedtimes and wake times to ensure the duration would be maintained as targeted by the study condition. So for the adequate sleep condition, participants were very good at maintaining their usual sleep duration. The time zero here is what we measured during this 2-week screening period. As I mentioned in the previous study as well, on average, they get 7.5 hours of sleep when they're screened to achieve more than 7 hours per night. And then the open circles is what we achieved when we asked them to restrict their sleep by delaying bedtimes by an hour and a half. They maintained this reduced sleep duration. And this is each participant's individual data for a change in sleep duration from their screening values during the sleep restricted condition. And these are the sleep durations that we achieved on average over the 2-week period. So roughly 80-minute difference in sleep duration between the two conditions. What we found was similar to Covacin, that sleep restriction increased body weight also by roughly half a kilo between the adequate sleep versus sleep restriction, and that waist circumference was increased as a result of sleep restriction over a 6-week period compared to adequate sleep. We've published on cardiometabolic risk factors. Sleep restriction, we found increased ambulatory blood pressure. This was in a study that was solely recruiting premenopausal and postmenopausal women. And when we looked at differences between pre and postmenopausal women, we found that sleep restriction was particularly pressure in postmenopausal women compared to premenopausal women. But these are data from ambulatory blood pressure. The wake time diastolic blood pressure and mean arterial pressure were increased in the black bars, which were sleep-restricted conditions compared to adequate sleep. We also evaluated the impact on glycemic control and found significant increase in fasting plasma insulin as a result of sleep restriction. Here it's in white. Sorry for the change in color schemes here, but white for sleep restriction, adequate sleep is in black. And we found no difference in fasting plasma glucose in the sample. But in postmenopausal women, when we adjusted for visceral adiposity, we found that fasting plasma glucose was slightly higher uh, in the sleep-restricted condition here compared to adequate sleep. When we measure or calculated HOMA-IR, we found that sleep restriction increased insulin resistance in the full group, so all women, and also separately when we evaluated in premenopausal women and in postmenopausal women. And we also showed that Matsuda index, which is an index of insulin sensitivity, was reduced with sleep restriction in postmenopausal women, specifically with a large effect size. We also evaluated oxidative stress in endothelial cells collected in these women at the onset and endpoint of each sleep condition. We found that sleep deprivation increased inflammation. We also found increased oxidative stress. You could see here depicted in by NF-kappa B was increased in a sleep restricted condition compared to adequate sleep. Oxidative stress by fluorescence intensity also increased. But contrary to what is often observed in animal models and Drosophila models, there is not an upregulated antioxidant response as a result of sleep restriction um, in our cohort of women. And you could see all of the antioxidants that we measured here, catalase, superoxide dismutase, heme oxygenase 1, mRNA, thyroredoxin reductase 1, and NADPH, quinone oxidoreductase. None of those were significantly increased by sleep restriction compared to adequate sleep. So we found only one marker to be significantly reduced as a result of sleep restriction in these cells, and it was defective in colonidylation 1 domain containing 3, which abbreviates to DCUN1D3, which is a binding target of colon 3. DCUN1D3 has been shown to regulate the endothelial antioxidant response. So with my colleague Sonia Angelic, we put together this potential mechanism as we observed from our data on inflammation and antioxidant response, really presenting that sleep restriction impairs this intrinsic antioxidant response. And so I'll show this here in a cartoon format, what happens, we think, during adequate sleep versus what happens during sleep restriction. So during adequate sleep, oxidative stress increases as a result of wakefulness, and this leads to an increase in serum response factor that upregulates DCUN1D3. I mentioned DCUN1D3 was a binding target of colon 3. So colon 3 in a resting state is typically bound to NRF2. So in the presence of increased DCUN1D3, colon 3 separates from this complex, and which allows NRF2 to translocate into the nucleus, bind to antioxidant response elements, and trigger the transcription of antioxidant genes to mount an antioxidant response to reduce oxidative stress. These pathways require growth hormone and melatonin. In the context of sleep restriction, we see upregulation of oxidative stress. More oxidative stress occurs during wakefulness, but despite this greater oxidative stress, serum response factor is not upregulated as it should, is not increased to the extent it should, and therefore DCUN1D3 is reduced, which I showed in the previous slide. Because there's less DCUN1D3, colon 3 remains complexed to NRF2. This complex is triggered for proteasomal degradation, and therefore NRF2 is not available for translocation into the nucleus, does not bind to antioxidant response transcription factors, and the antioxidant genes are transcribed. We're not mounting the appropriate antioxidant response. And we believe this really explains how there's potential increased oxidative stress as a result of sleep restriction that could lead to greater risk of cardiovascular disease. So overall, our findings reveal that sleep restriction, even a mild sustained sleep restriction for 6 weeks, raises blood pressure, reduces insulin sensitivity. I haven't shown these data, but we've published that as well, that it increases hematopoiesis, increases oxidative stress, inflammation, and leads to an increased risk of cardiovascular disease, which have contributed to the American Heart Association adding sleep duration to as an essential metric to evaluate when we're evaluating cardiometabolic health. So the American Heart Association had developed Life Simple 7 key metrics to evaluate cardiometabolic health that included healthful diet, having a normal body mass index less than 25, um, having high physical activity, not smoking, and having low levels of total cholesterol, blood sugar, and normal blood pressure. Now, sleep duration of 7 to 9 hours per night is included in Life's Simple 7 in 2022, became Life's Essential 8. But my colleague and I are interested in sleep beyond sleep duration. When we think about sleep, I mentioned in opening slides that there are so many people, over 60% of adults who report having low quality sleep based on having difficulty maintaining sleep and difficulty falling asleep. So sleep is more than just about sleep duration. And in um, in April 2025, we published an updated statement by the American Heart Association on multidimensional sleep health, where we note various sleep metrics that one should pay attention to that include sleep metrics that are relevant to the sleep period, but also the daytime period, because we know that sleep is experienced or sleep occurs at night, but the sleep experience extends beyond the nighttime and spills into the daytime. So we include factors like satisfaction when you wake up, how do you perceive the quality that you obtained the night before, and alertness and your ability to maintain optimal vigilance as key sleep metrics to also consider when we're talking about sleep as a multidimensional behavior, in addition to duration, efficiency, uh, timing during the day when sleep occurs, the regularity and the stability of sleep-wake patterns over time, presence, absence of sleep disorders, and sleep architecture. With my colleague Brooke Agrawal as part of the American Heart Association Strategically Focused Research Network, where she uh, put together a cohort of women, we noted that women who report poor sleep quality based on the Insomnia Severity Index, the Pittsburgh Sleep Quality Index, and also reporting time to sleep onset, was all of these factors were associated with inflammation despite sleep duration. So we showed that women who perceive having poor sleep quality and insomnia symptoms have greater vascular inflammation despite objective measures of adequate sleep. So really going into beyond sleep duration factors that are relevant for cardiometabolic health. More recently, I've been asked to review the literature on sleep irregularity and variability by ATVB, and this is a review paper that was published last month, highlighting these novel sleep patterns and how they influence heart disease risk, how sleep duration variability across days, having irregular sleep patterns, so shifting the timing of sleep across days of the week, how those relate to disrupted circadian rhythms, increased endothelial oxidative stress and inflammation that lead to an increased risk of heart disease and risk of major adverse cardiovascular events. So what should we do? From our paper or our statement on multidimensional sleep health, we put recommendations for various stakeholders, right, and various uh, groups that are involved in studying sleep, studying health and behaviors, and also treating patients. So we ask that researchers from various disciplines incorporate multiple methods of sleep assessment. So the sleep metrics that I mentioned in my previous slide are not necessarily solely measured from objective tools, but also require questionnaires. So we need to and have various measures of objective sleep. So not solely through actigraphy or polysomnography, but incorporating all of these measures as well as questionnaires to capture this information on these multiple dimensions of sleep. We also ask that clinicians across various specialties ask their patients about their sleep and recommended a simple open-ended question like, how is your sleep? To allow patients to really express themselves about the issues that are relevant to them. If we start asking targeted questions, then we may be missing really important elements of sleep that are troubling our patients. And also understand that sleep exists within broader individual, social, and societal contexts that are important when we're determining health outcomes. So what I've been really interested in studying in more recent years is how to improve sleep to enhance cardiometabolic health. We know quite a bit about how adverse sleep has a negative impact on health, but can we now study how improving sleep could enhance our cardiometabolic health? And we've turned to diet. My background as you all know now, is in nutrition. So it was quite comforting to start to think about how diet could be influencing cardiometabolic risk, cardiovascular risk through perhaps improvements in sleep, through improvements in melatonin levels by consuming adequate amounts of tryptophan, but also other key nutrients that may play a role uh, in our ability to produce adequate amounts of melatonin and serotonin that are involved in improving sleep quality and duration. So in January, this paper was published in the journal Medicine looking at the odds of circadian syndrome with those based on healthy eating index. Circadian syndrome is analogous to metabolic syndrome, basically the presence of four adverse health metrics like central adiposity, high triglycerides, glucose, blood pressure, or low HDL, sleep duration 6 hours or less, and having elevated score for depression on the patient health questionnaire. In the study of NHANES from 2015 to 2018, they found that the prevalence of circadian syndrome was almost 30%. And of those, over 80% had short sleep duration. It was a third most prevalent metric or adverse health metric in the list of adverse metrics in this circadian syndrome. And the most common combination of risk factors was central obesity, glucose, sleep, and blood pressure. And when they looked at multiple combinations of risk, the top three all included short sleep. But the reason I'm talking about this specific study is that they were interested in evaluating how odds of circadian syndrome were as associated with the healthy eating index, and they found that in NHANES, individuals who had higher healthy eating index had a reduced risk of having circadian syndrome. So what is the healthy eating index? 2015. So this would be your ideal healthy eating index score, score of 94, very high diet quality. You could see um, very colorful meals there, salads, fresh fruits and vegetables, whole grains, um, the low-fat, non-fat dairy, water. There's red wine in one of those pictures. But as you start going down in scores, you start seeing that the diet becomes a lot more white, we could say. We start seeing more packaged foods. So the middle panel is a healthy eating index score of 43, which is almost what the score was in NHANES. The average score was 50. So not quite as bad as the middle panel here, but pretty much very much in line with that. And then when you go to very low healthy eating index score, you start seeing very refined carbohydrates, higher saturated fats, added sugars, and processed foods. So we were interested to see how dietary patterns could be associated with sleep. In 2018, we published a study from data obtained from the multi-ethnic study of atherosclerosis, where they had very good diet information from exam one, and they had added sleep as an ancillary study in exam five and had actigraphy and polysomnography data. So we evaluated here the change in adherence to Mediterranean diet over that 10-year period and how that was associated with their sleep measured at year five. And we found that compared to those who maintained a stable adherence to a Mediterranean diet, those individuals whose diet got worse were more likely to report insomnia symptoms at exam five. And we found that so this is these data here. So if you had no change compared to those who reduced their adherence to Mediterranean diet, you were less likely to have insomnia symptoms. And in this box here, we showed that if you had an improvement in your diet compared to those who had a decrement in their diet score, so those who improved their diets were more likely to have better sleep duration than those who had a reduction in their adherence to Mediterranean diet, so whose diet got worse with time. We evaluated this as well in our cohort of women that I alluded to earlier, where we evaluated adherence to a Mediterranean diet in relation to sleep quality at 1 year. So this is baseline diet, showing that increasing scores on the Mediterranean diet were associated with better sleep quality overall using the Pittsburgh Sleep Quality Index, better sleep efficiency, fewer sleep disturbances, and we also looked at key food groups of the Mediterranean diet: fruits and vegetables, legumes, nuts, and dark breads. And specifically, fruits and vegetables and legumes were associated with better sleep quality, better sleep efficiency, in fruits and vegetables, fewer sleep disturbances. And similarly, trends for dark breads, so more whole grains, tended to be associated with better sleep quality overall and fewer sleep disturbances, though this didn't quite reach statistical significance. We also looked at data from the Women's Health Initiative. This was a study where we looked at glycemic index food consumption and found it to be associated with increased insomnia risk at 3 years. So a higher glycemic index represents foods that raise your blood glucose to a greater extent. So closer to pure white bread or pure sugar, for example. So women who had a diet that was higher in dietary glycemic index had higher risk of incident insomnia at 3 years. We can also calculate the glycemic load, which is the product of the glycemic index and total carbohydrate content of the food or the diet. And similarly here, increased risk of incident insomnia at 3 years, and dietary added sugars, which really reflects greater glycemic index as well, were also associated with increased risk of insomnia at 3 years. Conversely, lower glycemic index foods like non-juice fruits and vegetables were associated with a reduced risk of insomnia at 3 years. When we looked at dietary fiber in this study, it didn't quite reach statistical significance. There was a trend towards as well improvement with higher fiber intakes. And then more recently, this just came out last month, looking at again the women data from the Women's Health Initiative, adherence to a healthful diet. Here we looked at the Mediterranean diet versus the dietary approaches to stop hypertension, which is developed in the US, and look at how these two types of diets were associated with insomnia at 3 years, and found that overall higher scores on the Mediterranean diet and dietary approaches to stop hypertension were associated with a reduced risk of incident insomnia. Here we actually categorized women based on differently than we had in the past. So we looked at insomnia incidence as having either insomnia at baseline and 3 years, or no insomnia at baseline and developing insomnia at 3 years as an insomnia profile. And a no insomnia profile were women who did not report insomnia at baseline or 3 years, and also women who reported insomnia at 3 years, but not, I'm sorry, insomnia at baseline, but not at 3-year follow-up. So increasing risk of having insomnia with a reduced risk of having insomnia with healthier dietary profiles. And here, when we looked at food groups, we specifically focused on food groups that we hadn't already published on in the previous study that I described of glycemic index. So we looked at nuts and legumes, low-fat dairy, dietary sodium, red and processed meat, and sugar-sweetened beverages. And here, specifically, higher intakes of nuts and legumes were favorably associated with insomnia risk, so reduced risk with higher intakes. But those are population-based studies relying on self-report for diet, often also for sleep. So we looked at data from our prior study, the first study that I conducted looking at impact of sleep restriction on dietary intakes. And we looked at the data that we obtained in the habitual sleep condition, where participants spent 9 hours in bed. Here we had variability in sleep duration and sleep quality, and we were able to perhaps evaluate how diet influenced their sleep. So I mentioned early on in my talk that this study was done in a controlled feeding environment for 4 days, and then ad libitum diet for the last day. Sleep was measured using polysomnography every night. So the first question we asked was their diet different when when they self-selected their diet compared to the diet that we provided to them during those 4 days? And indeed, we found that dietary intakes were different. Participants consumed almost 500 calories more when they self-selected their diet. Their diet contained a little less protein, slightly more carbohydrates and fat, but markedly more saturated fat, 33% more saturated fat than what we provided to them in the controlled diet. That was designed to be a healthful diet. So then the next question was their sleep different at night when we looked at their sleep during the controlled diet versus ad libitum diet? Here we looked at a single night after 3 days of the controlled diet versus ad libitum diet. They achieved the same total amount of sleep, similar amount of stage 1 and stage 2 sleep, but less slow wave sleep in the ad lib after a day of ad lib diet, and much, much longer time to fall asleep in this condition compared to the controlled diet that we provided to them. So then we wanted to evaluate what was it about the foods that they selected that was associated with their sleep at night. So we found 3 nutrients that were specifically associated with sleep at night, and those were fiber, refined carbohydrates in the form of sugar, non-fiber carbohydrates, and saturated fat. So we specifically found that participants who consumed more fiber spent less time in stage 1 sleep and more time in slow wave sleep. Participants who consumed more sugar and refined carbohydrates had more arousals at night. And participants who consumed more saturated fat spent less time in slow wave sleep, suggesting that a diet higher in fiber with lower intakes of sugars and saturated fat would be associated with better sleep depth and architecture, really supporting the findings that we more recently published on based on population-based studies of more healthful diets being associated with lower risk of insomnia and better sleep quality. More recently, with my colleague at the University of Chicago, Eswata Sally, we pooled some data that we had where we evaluated dietary intakes during the day using food records with the ASA-24 and assessed sleep at night using wrist actigraphy. So we had data from 34 men and women who were a little less than 30 years of age and had normal to overweight BMI. They were all recruited to participate in sleep studies where they were required to sleep at least 7 hours per night. And as I mentioned, we measured food intake with records and sleep with restictography. And on average, each participant provided 6 paired measures of diet and sleep. And we evaluated their sleep fragmentation index and how that was associated with their diet. And we found that higher carbohydrate intakes were associated with lower sleep fragmentation index, mostly through greater intakes of fruits and vegetables. And I'm showing fiber because this was a trend here for higher fiber intakes to be associated with less fragmented sleep. Magnesium was also a trend, so greater magnesium intakes associated with less fragmented sleep. And I like to mention those two nutrients here because those are nutrients that we find in fruits and vegetables. So really supporting the fact that yes, we find carbohydrates to be associated with less fragmented sleep, but not any carbohydrates, mostly carbohydrates from fruits and vegetables that provide fiber, magnesium, and other sleep supporting nutrients. I also found a slight trend for worsening of sleep quality with increasing intakes of red and processed meats. So the data really converge over healthful dietary patterns as having beneficial impact on sleep. Dietary patterns that are represented here as like Mediterranean diet, higher in unsaturated fats with fish, nuts, seeds, legumes, whole grains, a lot of fruits and vegetables, and also a more Americanized pattern with low-fat dairy, uh, also different sources of monounsaturated fats being associated with better sleep quality. But also could unhealthful dietary patterns have adverse effects on sleep? So this is, what we were looking at in terms of a lower score on the healthy eating index, for example. And what would the mechanisms be for those dietary patterns having impact on sleep? So we've been really looking at melatonin synthesis as a potential mechanism by which a better diet could improve sleep. Melatonin, as you may recall, is produced entirely from tryptophan. Tryptophan is an essential amino acid, meaning that our bodies cannot produce this amino acid. We must obtain it from food sources. And the conversion of tryptophan to melatonin requires multiple steps that all require various cofactors in the form of various vitamins B6, magnesium, vitamin B5, zinc is also involved in this process. And so a lot of nutrients that we must obtain from foods being needed for tryptophan to be converted to melatonin. And so what do studies show when they evaluate melatonin production from various foods? So the next two slides, I'll be presenting data based on different food supplements. So this is a study that looked at tomato supplementation and its impact on sleep quality in postmenopausal women. Uh, they note in the study that of all tomato varietals, beefsteak tomatoes seem to have the highest level of melatonin. So they provided 250 grams of beefsteak tomatoes to postmenopausal women to consume for 8 weeks, 2 hours before bedtime. So one group of women was randomized to the tomato group. The other group was asked not to consume any tomatoes at all for this period of 8 weeks. And what they found was that the tomato group had a significant increase in 6-sulfatoxymelatonin production compared to the control group at the end of the 8-week supplementation period, which corresponded to an improvement in their sleep quality. So these women all reported having poor sleep quality at baseline, and this was significantly improved in the women randomized to the tomato group compared to the women randomized to the control group avoiding tomatoes. Other fruits were also shown to increase melatonin production. This study enrolled 12 male volunteers and randomized them to consume juice from 1 kilogram of oranges, 1 kilogram of pineapple, or 2 whole bananas in randomized order. And they measured serum antioxidant capacity and melatonin over a 4.5 hour period after consumption of the fruit juices. They found an increase in serum melatonin production. The participants were all in dim light during this test. At 2 hours after consumption of the fruit juices relative to baseline. And there was also an increase in antioxidant capacity following consumption of the fruit juices compared to pre-consumption. And they found that these values, specifically for melatonin, peaked at 2 hours and returned to baseline within the 3 hour window. So, is there a possibility to improve sleep as a means to improve cardiometabolic health? The studies that we find, or the dietary patterns that we find to be associated with better sleep quality, are all patterns that are recommended for better cardiometabolic health. We're talking about the Mediterranean diet, the DASH diet, but also the MIND diet that's high in berries and foods that would be supportive of cognitive function. But what's noteworthy about these diets is that they all contain large amounts of fresh fruits and vegetables, whole grains, unsaturated fats, and could be good sources of melatonin, but also polyphenolic compounds and dietary fiber that influence the gut microbiome. By influencing the gut microbiome, these diets tend to cause increased production of short-chain fatty acids, specifically butyrate, which has been shown to upregulate circadian clock genes. They're also involved in reducing inflammation and oxidative stress, all of which could lead to better sleep quality and reduced insomnia risk. Conversely, we've shown that increased intakes of ultra-processed foods is associated with increased risk of insomnia. So really going hand in hand with recommending healthful dietary patterns to improve sleep. So I like to end here with this slide that perhaps it's time to make dietary recommendations for better sleep health, but we do have more questions to answer when we talk about this topic because we need to have more information on the different mechanisms, also studies in special populations. A lot of the studies that have been published to date have not necessarily focused on individuals who have poor sleep quality or have trouble sleeping. And I think that it's important to conduct these types of studies in individuals who could benefit most from improving their diet to improve their sleep. We also should all be cognizant of the impact of timing of food and nutrient intakes for sleep. And that's also something that people in the obesity field have been starting to ask about when we're looking at studies of time-restricted eating. The issues with these studies is that they're not often not designed to evaluate sleep, and sleep is often asked as an afterthought. And I think we need to design studies to specifically look at how timing of food and nutrients influences sleep, also to impact cardiometabolic health. So with that, I'd like to end here, entertain some questions. I'd like to acknowledge funding from the American Heart Association, National Heart, Lung, and Blood Institute, the Irving Center, or the Irving Institute for Clinical and Translational Research, Obesity Nutrition Research Center at Columbia, and the people that I collaborate with, research assistants and many students who have collaborated and made all the work that I've discussed possible. So thank you very much.
Thank you so much for this amazing talk. Patients in clinic often ask me what food should they be eating to improve their sleep, and so now I have like some answers or specifics I could give. So thank you. If anybody has some questions, you can put them in the chat box, or you can unmute yourself and ask them. It looks like there's a question from Adam. Is there solid data to suggest that eating breakfast uniquely beneficial as opposed to skipping breakfast and eating later in the day. I have always been skeptical of messages that say breakfast after awakening is the most important meal of the day.
Yeah, I'm a big proponent of breakfast actually. I think that that breakfast is an important meal. It sets the tone. Actually, we published a statement from the American Heart Association on meal frequency, meal timing, and cardiometabolic health. So in terms of cardiometabolic health, most of the research um, shows that eating earlier in the day is better for your health. We actually also have a study where we're evaluating shifting the timing of eating in relation to wake time and how that influences energy balance regulation. And we're finding that eating meals, identical meals, later in the day reduces fat oxidation. So I think that's important. We also know we're more insulin resistant later in the day, so having foods earlier in the day is better. In terms of how it influences sleep, I think we need more targeted studies evaluating how specific meal times influence sleep quality and sleep duration, and multiple metrics of sleep. Because sometimes sleep duration may not be impacted, but sleep quality could.
Okay. Thanks. And then I think Dr. Wojak has a question for you. You're unmuted.
Hooray. Hi. My name is Brian Wojcik. So really interesting talk. I'm an endocrinologist and sleep doctor and obesity doc actually. Um, so squarely in my interest. With the mechanisms that you proposed, do you think it's just better regulation of melatonin? Because if we infuse people with melatonin, it could actually cause circadian disruption. So do we think that adding all these nutritional cofactors is just improving how melatonin is regulated and therefore improving our circadian rhythm? And then is there data out there in, let's say, like a bariatric surgery population or malnourished patients, and there's
Nope, you're muted now.
Oh,
uh,
Okay.
and 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 uh and in malnourished patients, and how that might affect their sleep quality. I
Mhm.
think it's really fascinating stuff, but I definitely see plenty of patients with that have undergone bariatric surgery, and it'd be an interesting addition to think of this. That's part of the story.
Mhm. So to me, it's about having the right nutrients at the ready when, the
Hmm.
body's ready to produce melatonin, not necessarily infusing, injecting, supplementing.
Hmm.
We know that deficiencies in many of these nutrients actually cause sleep difficulties. So, you
Hmm.
know, deficiency in iron, deficiency of magnesium, deficiency in selenium actually was also shown to be associated with worse sleep quality. So making sure that the nutrients are there available for proper production of melatonin at the right time. And in
Okay,
terms
so
of
so we
your question, yeah.
yeah, so we do think it's basically it allows for better regulation, because if you don't have those cofactors, these nutrients, you're having going to have trouble producing melatonin,
Yeah,
and therefore it's going to be, it might cause circadian disruption.
that would be my thought, yes.
Okay, and then we would then so is there data in the malnourished population on this?
Um, there are studies of patients with anorexia who have disturbed
Hmm.
sleep. So, malnourishment, yes. Um, and that, but they're older studies, so we don't know like more recently in terms of um very severe um very severe malnourishment, how that influences sleep. So we know like from people
Hmm.
with anorexia, but less severe is what I want to say. Uh,
Right.
we don't really have good information.
So then I think the interesting study would be to look at bariatric patients,
Hmm.
to say what because because many of those cofactors that you had on that slide, right?
Hmm.
Those are deficiencies in those
Yeah.
patients, right? You have iron, you have B12, you have calcium. We don't check mag, but I'm sure they have some mag deficiencies, you know?
Hmm.
And so I bet you that there's an interesting study in a bariatric population.
Yeah, it would be very interesting to look at for sure.
All right, I'll
I think
stop.
that so sleep. I think that obesity researchers are starting to think a lot more about sleep, which is great, because we know from our work that adequate or insufficient sleep influences energy balance regulation and influences your ability to lose weight, maintain lost weight, impacts resting metabolic rate. It impacts the quality of the weight loss. So I think it's very important to start looking at or evaluating sleep in different populations undergoing obesity treatment.
All right, thank you.
We have another question from Dr. Yagi. He said, can you speak to potential confounding factors, particularly observational studies when examining the relationship between diet and sleep, such as socioeconomic status or timing of food consumption?
Hmm. So socioeconomic status we always adjust for. So to the extent that these data are collected, but oftentimes, education, marital status, income, those insurance status in some of the studies, so too, those usually are data that are collected and we adjust for in analyses. The timing is not. So that's one where we really need to do a better job in the future at looking at the timing of eating and how that is relevant to sleep, where we're looking at dietary intakes and sleep. Because, and also so the caveat too is that a lot of data from population-based studies are from questionnaires. And so when you're asking about questionnaire, you're getting at relatively good data about sleep quality over a long period of time. Uh, but you don't get granular data in terms of meal timing.
Do you think sleep providers should be asking their patients with insomnia about what their diet is and potentially referring them to a nutritionist?
I think so. I think so. There, we talk about dietary patterns. So I like to think about, better foods to consume for better sleep. But there's also, what foods not to eat, right? What beverages not to consume to ensure you have better sleep. So I think that most um, behavioral sleep medicine specialists will, think about alcohol, caffeine, those types of, or drinking too much liquid too close to bedtime. But, I think that there are other foods, so what I've mentioned
Yeah.
in my talk that are relevant and important to address. And we know that the American population does not follow a very healthful diet. So there's a lot of work to be done.
Do you have any resources that we could potentially give patients to, or suggestions on resources in terms of um, oh, you should be eating more fruits and vegetables or like less of the saturated fat and how to help them gauge that if they don't have access to a nutritionist?
Yeah, so this is, we were talking about this before the talk, and you were talking about my book that I published, and so it was, what I was gonna tell you before the my talk was that I went to the Canadian Sleep Society meeting last spring, and someone came up to me and she said, "Thank you very, very much for publishing this book. People ask us all the time, what should they be eating? Could they be eating something else?" And should I refer them to your book? And so I think that was really, I was, quite very, very flattered that she would do that. But that was basically the reason behind publishing a book where there is science, but also recipes, because people don't necessarily know how to cook these days. And it's one thing to say, oh, you should eat more fruits and vegetables and you should eat more whole grains, but people don't know what whole grains they should focus on and what do you do with barley and what's buckwheat and how do I put kale in my dinner, what do I do with lentils? So those are important questions, and I think giving resources like that is important.
Yeah. We actually have two more questions. We're at 3 o'clock, so I mean, if you have time to answer one or two more questions, if not, we can like wrap up here.
Sure.
Um, so one question is, did you show that two most significant objective findings on diet and insomnia was percentage of uh, N3 sleep and sleep onset latency? And then the next comment was, thanks for an excellent talk. Your work and that of others suggests that sleep variability, not just short sleep, relates to adiposity, inflammation. In clinic, how do you dose regularity, and what's a realistic target for bedtime consistency that still moves outcomes?
Okay, so the first question, when we compared sleep on the two different dietary patterns, it was slow wave sleep and sleep onset latency that was significantly different. When we looked at how diet influenced sleep, we let them self-select their food intake, um, slow wave sleep and arousals were the major ones that were impacted by saturated fat and fiber and refined carbohydrates. Um, and then in terms of regularity of sleep, that's something that we're actively trying to figure out what the optimal cutoff should be in terms of reducing variability in the timing of sleep. So one thing that's easy to do in the clinic, or relatively easy to do, is to get the bedtime, wake time standard deviation when you measure sleep over multiple days. So if you have your patient tell you, what time they go to bed every night for 7 days, you can calculate that standard deviation. Um, so stay very stable sleep is having a standard deviation less than 30 minutes. And then as you deviate from that, some people have a standard deviation of their sleep of 90 minutes. And so it's all over the place. They're going to bed, at 11 and 2 and midnight and 10 and 3. And so those would be very highly variable. Now, we actually have a study funded now where we're looking at how stabilizing bedtimes can impact glycemic control and body composition. And the cutoff we had for enrolling individuals who had variable sleep was a bedtime standard deviation of 45 minutes. And and so now we have people who have much higher bedtime standard deviation than 45 minutes, and they were randomized to stabilizing their sleep. The goal was to get to less than 45 minutes, but if they were at 100 minutes and they went down to 70 minutes,
Mhm.
is that sufficient? We don't, that's what we're trying to answer this question with the data that we have at the moment. Like, is it, any reduction would be beneficial? Do you need to get under a specific threshold? Do you need to reduce by a specific amount? So I think those are all questions that are important to answer that we need to have that we need to address at this point.
Well, we look forward to like what your answers are, and thank you so much for this presentation. We really appreciate it, and I think we can wrap up here, and we'll see everybody again next week. Thank you.
Thank you. Thank you for having me. Have a great afternoon.
Bye. You too.
Bye-bye.